Year 5, Lesson 6, Extensive Exercise, Question 3. Double-decker buses can hold up to 54 people. So let's call X the number of double-decker buses. And single-decker buses can hold up to 36 people. So let's call Y the number of single-decker buses. Therefore, we've got X and we've got Y. And in total, they're going to add up to 378 people. Okay, so let's first set out our two X's and Y's so we know what they mean. Now we can write an equation. So if every double-decker bus holds 54 people, that's going to be in total 54X people. So each X, each double-decker bus, we need to multiply by 54 because it says that every bus must be full, must be completely full. 54X plus each Y, each single-decker bus has 36 people, so that's 36Y. And in total, that's equal to 378. Now, of course, we could solve this, but looking at those numbers, it's pretty much clear straight away that we've got a multiple of 9 in there. We can actually find a bigger highest common factor. But I think the most straightforward step would be to notice that we've got multiples of 9 here and to divide by 9. So that leaves us with 6X plus 4Y is equal to 42. Of course, you can do a short division or a long division to find that. And then immediately we can see they're all even. So yes, we did have a factor of 18, but I don't expect you all to spot the multiple of 18 straight away. But we can divide by 2 again and we get 3x plus 2y is equal to 21. And now we've got an indeterminate equation that we can solve. So starting, well, we could use some enumeration and list multiples of x. However, one thing I can notice here is we can do some odd even analysis. 21 is clearly an odd number. 2y is always going to be an even number because it's a multiple of 2, which leaves us with 3x definitely being odd. And if 3x is odd, then we know that x has to be odd because it can't be an even number, otherwise 3x would be even. Therefore, x is odd. So we can start out by listing some of the multiples, some of the odd multiples of x, starting with x equals to 1. And we can substitute into our simplified equation over here, which would give us 3 plus 2y is equal to 21, which of course tells us that 2y equals 18 and y is equal to 9. So we found one solution, but remember this question asks us for the smallest number of buses. So we should carry on and find the next solution. Using our coefficients, I can increase my x by the y coefficient. So my next solution is x equals 3. Of course, this makes sense as it's the next odd multiple that we were going to try anyway. And then we can substitute. That gives us 3x is 9 plus 2y equals 21. And therefore 2y equals 212. And y is equal to 6. Of course, we could have just subtracted the x coefficient. There's our second solution, and I'm going to find the last one by using the coefficients to save us some time. So we're going to increase our x by the y coefficient. So x is now going to be 5. So it's 2 bigger than the last solution. And my y is going to decrease by the x coefficient. So my y is going to decrease by 3 and become 3. Now, in terms of the next solution, straight away I can see that if I was to decrease my y by the x coefficient again, I'm going to end up with y is equal to 0. And that's not a possible solution because all the buses need to be filled. So we don't like that solution. And we just need to add up to find out which one of these gives us the smallest number of buses. So here we've got x is equal to 1 and y is equal to 9. So that's 10 in total. Then we had x is equal to 3 and y is equal to 6. So that's 9 in total. This is the smallest so far. And then we've got x is equal to 3 and y is equal to, x is equal to 5 and y is equal to 3, giving us 8. So that's our answer and our smallest number of buses.